So be careful, it's not the address of the current instruction, it's the address of the next instruction. So the address of the next instruction will be in the program counter register. Okay, and another important thing is here you can write this one. For example, jump is the combination of by copying a new address into PC. Okay, we know this. And the JAL function implementing by copying the specified address into the PC to the program counter. Okay, and you can write this tutorial for at the beginning of the lab sheet. And also this is something important here. The another point is that if you have different procedure called, for example, if you remember from the high level programming language, you have one main function and you have one subsection that you have another function is the nested function, and in that nested function you have the another nested function and something like this. Here we can have the same. Okay, so here we can write that if a procedure call another procedure call, it means that if a function is in the another function and so on, then the old value of the register number 31 must be saved into the last in first out task. So when, for example, you have a function in the function in the function in the function and you use the JAL, the address, how we save the address in our stack in this manner, last in first out. Okay, you know about the last in first out, so it's like a stack, last in first out manner. Okay, so this is the manner that the address saved into register. And also here we have one table that you can see here, the different register and the name of the register, number of the register and convention. And here let's go to the lab sheet, to the experimental work. In this experimental work we are going to use the JAL and GR. Okay, JAL function and JAL instruction and GR function instruction, sorry. For example, just imagine that we have this kind of function. This function is in the C file. Okay, in this function we are going to sum the element of the array. Okay, this is the code of the C program to find the sum of the member of the array. Okay, you can see that this is a function name, this is your input, and here check that if the size is 0 or no. The size is the size of the array. So if the size of array is 0, it means that you don't have any array and return 0, but else it means that if the size of array is more than 0, it will return this value, the sum of the member of the array. Okay, and if we are going to convert this function to the MIPS assembly language, this is the code of that one. Okay, and if you check the code line by line, in many part of the code we put some comment for you. You can find it, and you can find that this code is corresponding to this function in C programming language. Okay, everything is clear. For example, here you use the JAL. Okay, JAL to fun. When you use the JAL to fun, it means that fun must be a label. Okay, because you are going to jump to this label. So when the compiler reach to here, jump to this line. Or for example, when you use the JAL here again, you are going to call a function. You are going to in the CMP 325 and in the MIPS language, when you use the JAL and in front of the JAL you have a label, it means that you are going to use a function. Okay, so when the compiler reach to this line again, jump to this line. Okay, again jump to this line. And also you can use the GR. It is another jump. You can see this is the return. Okay, when you use the GR $RA, it means that's the really return. Okay, and the other things, you have LW to load it, you have LY, you have a multiplication, and you have a add function. You save your value with the SW, Another thing is you have a main function, everything is there. You have